Let us evaluate definite integral. Now the difference of this between indefinite is that you actually have an upper and a lower limit. So for the first problem, the integral of x squared from 2 to 1. So first up, we're going to evaluate the integral of x squared. Just a recall, the integral of x to the power of n of dx would be equal to x to the power of n plus 1 over n plus 1. So for example, you have an integral of x to the power of 4 of dx. It would be equal to x to the power of 4 plus 1 over 4 plus 1, or it would be equal to x to the power of 5 over 5. So for this, the integral of x squared would be equal to x to the power of 3 over 3, and put your upper and lower limit, which is 2 and 1. So next up you're going to do here is to substitute these values into x. So first up, substitute 2 into x. So this would be 2 to the power of 3 over 3, and subtract it by substituting the value of the lower limit, or 1, into x. So this would be minus 1 to the power of 3 over 3. So let's solve. 2 to the power of 3 would be 8 over 3, minus 1 to the power of 3 would be 1 over 3. And so, since they have common bases, we can just simply subtract the numerator. So 8 minus 1 would be 7, and copy the denominator, which is 3, and that is your final answer. Let's move on to problem number 2. The integral of x cubed from 3 to 1. So, integral of x to the power of 3 would be x to the power of 4 over 4, ranging from 3 to 1. Or you can actually just write it like that if you are confused. So, substitute 3 first. This would be 3 to the power of 4 over 4, and subtract it by putting value of 1 on x. So this would be 1 to the power of 4 over 4. So 3 to the power of 4 would be 81. 1 to the power of 4 would be simply 1. And so once again, they have common bases, which is 4. So just subtract the numerator. 81 minus 1 would be 80, divided by 4, which has the final answer of 20. Next up would be the integral of 3x plus 2 from 4 to 0. So, whenever you encounter a polynomial, you can just integrate it one by one. So, let's move first with 3x. So, this is simply the integral of 3x dx. You can actually put 3 outside the integral since it is a constant. So, this is 3 integral of x. And so, you can focus on this. The integral of x would be x to the power of 2 over 2. And you can multiply 3. So, you are given an answer of 3x squared over 2. So, that is your integral for 3x. Next up would be the integral of 2. So, you can rewrite this as 2 of dx. So, you can put 2 outside the integral, which makes it 2 integral of dx, and the integral of dx is simply x. So, this would be 2 multiplied by x. So, you're given a final answer of 2x. Keep in mind, if you encounter a problem like a dy, know that the integral of dy is y. It corresponds really on the letter of this. So this would be plus 2x ranging from 4 to 0. So put 4 first into the x value. So this would be 3 multiplied by 4 to the power of 2 over 2 plus 2 multiplied by 4. And subtract it by putting the lower value on the x. So this would be 3 multiplied by 0 squared over 2 minus 2 multiplied by 0. You can actually see here that this value would all be equal to 0. So for this one, 4 squared would be equal to 16. And 3 multiplied by 16 would be equal to 48. Divide by 2. Plus 2 multiplied by 4 would be equal to 8. And so 48 divided by 2 would be equal to 24 plus 8. And you have a final answer of 32. The integral of x squared from 2 up to negative 2. So, take the integral of x squared first, which is equal to x to the power of 3 over 3, ranging from 2 up to negative 2. So, substitute it. This would be 2 to the power of 3 over 3 minus negative 2 to the power of 3 over 3. And so, focus on here first. 2 to the power of 3 would be equal to 8 minus negative 2 to the power of 3. This is simply equal to negative 8 over 3. Note that negative 2 to the power of 3, whenever this is in the parenthesis, you must multiply all of it by itself. So this is equal to negative 2 multiplied by negative 2 multiplied by negative 2. Negative 2 multiplied by negative 2 would be positive 4, and multiply this by negative 2. It would be equal to negative 8. So that brings our answer to negative 8 over 3. And so you can see here, negative and negative, you can actually make this positive. So 8 over 3 plus 8 over 3. Since they have common bases of 3, just add the numerator. So your final answer would be equal to 16 over 3. The integral of x squared plus 2x plus 1 from 1 to 0. So, let us start first by taking the integral of x squared, which is x to the power of 3 over 3. Next up, taking the integral of 2x. Now once again, let me just rewrite this for simplification. The integral of 2x. So, you can put 2 outside the integral since it is a constant. And the integral of x would be equal to x squared over 2. And so if you multiply this, this would be 2x squared over 2. And you can actually see that 2 here will cancel, leaving you with an answer of x squared plus the integral of 1. Know that integral of 1 dx is also equal to the integral of dx, which is equal to x. So, ranging from 1 to 0. So, this would be 1/3 over 3, 1 to the power of 3 plus 1 to the power of 2 plus 1 minus 0 to the power of 3 over 3 plus 0 to the power of 2 plus 0. This is all equal to 0. So 1 to the power of 3 is simply 1. Plus 1 squared is also 1. And copy the rest. So since we don't have a common denominator, we must put that. So this would be 3, 3, and so this would be also 3. And so 3 plus 3 plus 1 would be equal to 7 over 3. And so that is your final answer. The integral of x cubed minus x from 2 to 1. So take the integral of x cubed first, which is equal to x to the power of 4 over 4. And the integral of x, since it is a minus sign, just put negative here, or a subtraction sign. So the integral of x would be equal to x squared over 2, ranging from 2 to 1. So substitute 2 first. This would be 2 to the power of 4 over 4 minus 2 squared over 2. Subtract this by putting 1 on x. So this would be 1 to the power of 4 over 4 minus 1 squared over 2. Two to the power of 4 would be equal to 16 over 4, which makes this 4 minus 2 squared is 4. Divide by 2, which makes this 2. Minus 1 to the power of 4 is 1. 1 squared is also 1. So 4 minus 2 would be equal to 2. And 1/4 minus 1/2 would be equal to negative 1/4. And so 2 plus 1 over 4, which makes this 9 over 4. Problem. The integral of 2x plus 1 all raised to the power of 3 from 3 to 0. So for this, whenever you encounter an exponential, like something like this, you can use a technique called U substitution, wherein you can substitute this into a variable, let's say u. So let u here be 2x plus 1, and let us take its derivative. So this would be du equal to the derivative of 2x would be 2, and the derivative of 1 is 0, and multiply this by dx. And so let us take the value of dx, so put 2 to the other side, so this would be du over 2. And so this would be the integral of 2x plus 1 is equal to u to the power of 3, and multiply this by dx, which is equal to du over 2. And so for the upper and lower limit, we must remake this, because this upper limit of 3 and lower limit of 0 corresponds to the x value. But since we substituted it, we must also substitute this. So let's use this. U equal 2x plus 1. So let us substitute 3 first into the x here. So this would be u is equal to 2 multiplied by 3 plus 1. So this would be equal to 2 multiplied by 3 would be 6 plus 1 would be 7. So the upper limit would be 7 now. And for the lower limit, which is 0, 2 multiplied by 0 plus 1. So it would be equal to 1. So this is the brand new upper and lower limit, which corresponds to the u substitution. Don't worry, because we will solve this later on without u substitution so that you can see. And so, since this is a constant, you can actually put this outside the integral. So this would be 1/2, because know that this is a denominator and this is a numerator. 1/2 the integral of u to the power of 3 of du from 7 to 1. And now, you can actually solve this by power rule. So this should be 1/2 multiplied by the integral of u to the power of 3. This is equal to u to the power of 4 over 4 from 7 over 1. And so, put 7 on the u variable first. So this should be 7 to the power of 4 over 4. And subtract this by putting 1 on the u. So this should be 1 to the power of 4 over 4. Seven to the power of 4 would be equal to 2,401 over 4 minus 1 to the power of 4 is 1. And so, since these both have common bases, you can actually subtract the numerator now. So this should be 1/2 multiplied by 2,401 minus 1 would be 2,400 over 4. So, multiply 1/2 by this, you would have an answer of 2,400 over 8, or it would be equal to 300. So, know that the answer here is 300. So, let us try the other way when we won't use the substitution. But keep in mind, you can use this whenever you encounter a difficult problem in order to simplify it. So, let us solve this via expansion method. So know that a plus b to the power of 3, which corresponds to this. The expansion formula for this would be a to the power of 3 plus 3a squared multiplied by b plus 3ab squared plus b to the power of 3. So a here in this case is 2x and b here is equal to 1. So by that, the integral of this from 3 to 0, this is the expanded formula of this. This would be 8x to the power of 3 plus 12x squared plus 6x plus 1 of dx. Know that 8 to the power of 3, 2x to the power of 3, 2 to the power of 3 would be 8, x cubed would be x cubed, which makes that first. Three multiplied by a squared, which is 2x squared multiplied by v, which is 1. So 3 multiplied by 4x squared, which is equal to 12x squared. And so on. And so, you can actually evaluate this integral one by one. So let us start with the integral of 8x to the power of 3. It would be equal to the integral of x to the power of 3 would be x to the power of 4 over 4 plus 12 multiplied by the integral of x squared, which is equal to x to the power of 3 over 3 plus 6 multiplied by the integral of x, which is equal to x squared over 2 plus 1 dx, or the integral of dx is equal to x, ranging from 3 to 0. So let us substitute the value here. But first, let us simplify this. 8x to the power of 4 over 4. This would be equal to 4x to the 2x to the power of 4. For this, 12 divided by 3 would be equal to 4. 6 divided by 2 would be equal to 3. And so this would be plus 4x cubed plus 3x squared plus x, ranging from 3 to 0. So substitute 3 first. This would be 2 multiplied by 3 to the power of 4 plus 4 multiplied by 3 to the power of 3 plus 3 multiplied by 3 to the power of 2 plus 3 minus, putting 0 here, 2 to the power of 0 of 4 you can see here that it is all equal to 0. And so you can either use a calculator here or do it manually. 3 to the power of 4 would be equal to 81. So this would be 2 multiplied by 81 plus 3 to the power of 3 would be equal to 27 plus 3 multiplied by 3 squared, which is equal to 9 plus 3. Two multiplied by 81 would be equal to 162 plus 4 multiplied by 27 would be 108 plus 3 multiplied by 9 would be 27 plus 3, which all equal to 300. Which, as you can see here, it has the same answer as our substitution method earlier. For the last problem, the integral of x multiplied by the square root of x squared plus 1 from 1 to 0. So for this case, we absolutely need to use a u substitution because we are dealing with a square root here in order for a simpler calculation. So what we want to do here is to substitute this as u. So let u here be x squared plus 1. And so taking its derivative of x squared would be 2x, derivative of 1 would be 0. Multiply this by dx. And so dx right here would be equal to du over 2x. So putting the values in here, this would be the integral of x multiplied by the square root of u multiplied by the value of dx, which is equal to du over 2x. And so let us find out the new upper and lower limit for this. So from the equation of u equal x squared plus 1, so let us find out the upper limit first. This would be u equal to 1 squared plus 1. It would be equal to 2. So the new upper limit would be now 2. And for the lower limit, it would be 0 squared plus 1 from this. So what you're left with here is 1. So that makes it the new lower limit. And so simplify the integral now. You can actually see here that x here and x here would cancel. And you are left with 2, which is a constant. And so you can put it outside the integral. And so you are left with 1/2 the integral of square root of u du from 2 to 1. Now, whenever we are dealing with an integral, we would want it to be under exponent form. So know that square root of u is equal to u to the power of 1/2. Square root of cube root of u would be equal to u to the power of 1/3. And the fourth root of u would be equal to u to the power of 1/4. So in our case, it is a square root. So this would be equal to u to the power of 1/2. And so like the reason for this would be to use the power rule. So we would want it to be on their exponent form. So this would be 1/2 the integral of u to the power of 1/2. So this would be to the power of 1/2 plus 1 over 1/2 plus 1 from 2 to 1. 1/2 plus 1 would be equal to 3 over 2. And so by simplifying this, you can put this fraction on the numerator, but by doing that, it will reciprocate. It would be 1/2 multiplied by 2/3 of u to the power of 3/2 from 2 to 1. So 1/2 multiplied by 2/3 would be, or you can actually see here, this 2 will cancel, leaving you with a value of 1/3 of u to the power of 3/2 from 2 to 1. So put 3 on the u first. This should be 2 to the power of 3/2 minus 1 to the power of 3/2. So if you're using a calculator, you can easily solve this. But if you are doing this manually, let us do it. So whenever you have an exponent of a fraction, you can rewrite this as like this. So we have a fraction of 3/2. This is equal to 3 multiplied by 1/2. And so by rewriting that, 2 to the power of 3 multiplied by 1/2 minus 1 to the power of 3 multiplied by 1/2. So the reason that we are doing this is so that we can simplify this one by one. So you can actually see here, 2 to the power of 3. This would be equal to 8. So this would be equal to 8 to the power of 1/2. Note that, as we had said earlier, the square root of u is equal to u to the power of 1/2. So in the similar case, we have an exponent of 1/2 here. So we can rewrite this as a square root of 8. And so for this, 1 to the power of 3 would be simply 1. And the square root of 1 is simply 1. And so simplifying this, let us simplify this square root. So let us see the factors of 8. It is equal to 1, 4, and 8. So the greatest square root of the greatest square here is 4. And so this would be equal to 1/3 multiplied by square root of 4. Multiply this by 2. Note that this is all equal to 8. But we just rewrote it like this. And subtract this by 1. And so, taking the square root of 4, it is equal to 2. So this would be 2. And multiply this by square root of 2. So this would be 2. And subtract this by 1. And so, this can either be your answer, or if you want, you can do it like this. 2 multiplied by square root of 2 minus 1 over 3. Or if you want to put this into your calculator, it would be square root of 8 minus 1 over 3. But if you want the decimal value, it would be equal to 0.6095.